Today we'll be looking at pyramids. A pyramid is different from a prism in that you have all of the faces but one meets at a common vertex. So the vertex, if you recall, is that top point right there. The bases are the bottom of the pyramid, in which case each one of these are regular polygons. And so we call these regular pyramids because the sides of each one of those polygons are congruent to each other. So you'll see that we name the pyramid based off of the base. And so in the first one, we call that a triangular pyramid because we have an equilateral triangle being the base. The next one over, it's a rectangular pyramid if all of the sides are congruent. You see sometimes it's called a square pyramid, which you'll see down here. I'll go ahead and move the page so we see it a little bit more clear. But here you see that the diagram is a regular square pyramid in which the assumption is that all four sides are congruent. Now there's a few things that we'll notice. The lateral faces are all triangles in a pyramid. And I will go ahead and highlight just one of them so you can see. So in orange, let's go ahead and highlight this. This would be considered a lateral face and it's a triangle. The number of faces that you see, lateral faces that you see, also corresponds with, if you take a look at the rectangular pyramid, a rectangle for the base you have 4 sides to a rectangular pyramid, and if you count the number of lateral faces or triangular lateral faces that you have, you also see that you have 4. So the question that you have here, how does the number of lateral faces compare with the number of sides? Well, we just counted and it is the same. So the same. The question above that, we talked about with the prism, that lateral area just meant that you added the area of the sides, the lateral faces. And in this case, we said that the lateral faces were triangles. So to find the lateral area, you are finding the area of a number of triangles. In order to do that, we have to consider a feature of the pyramid that is unique to just the pyramid, and that's something called a slant height. And so slant just indicates that the height of each one of your lateral faces has a slant to it. So I'm going to do the best I can to draw the slant height here. Okay, you see that this is the height of that particular lateral face. And we want to keep in mind that right here, that's the slant height. And that the slant height happens to divide the base so that this segment is congruent to this segment. So we want to keep that in mind. And if I was standing at the top of, say, this rectangular pyramid, and I asked you how high am I, how far up am I on this triangular pyramid, it wouldn't be measured by the slant height, but by the altitude. And the altitude is if you had a hole in the middle of that pyramid and you were to drop a rope straight down. So in purple, I'm trying to do the best I can to draw a line that goes straight down. That is perpendicular with the base at the bottom. That is what we call the altitude. So that is a different measurement than the slant height that you have coming down the side of the pyramid. Okay, so all of those are important features of a pyramid to help us eventually be able to find the area of the lateral area and then eventually the surface area and total area of the pyramid. Let's go ahead and move on to the next page and talk about that. How is the lateral area of a pyramid 1/2 PL? So I'm going to go ahead and give me a minute here. I'm going to go ahead and copy this picture that you see here of a regular square pyramid and talk about how we can show that the lateral area is 1/2 PL. So now if I copy. Let's go ahead and see. Give me a minute here as I figure this out. Copy. And let's go ahead and paste that here. Okay, so now if we're finding the area of the lateral area of this pyramid, how is it that it's 1/2 PL? So let me go ahead and color in one of these lateral faces. So if we take a look at that lateral face, and let's say we call the bottom here, let's go ahead and label some of these features. So let's call the slant height L. Okay, that's the usual abbreviation for that. And let's call the base right here X. So if I was to find the area of that one particular lateral face, and we see that since this is a square pyramid, we have 4 of those, the area of that triangle is equal to 1/2 the base, which happens to be X, times the height of that triangle, which is L. Now we count up the number of triangles we have 4 of those. So the area of the lateral area would be equal to 4 times 1/2 X times L. If I rearrange things a little bit and put together 1/2 and put together 4X and put together L, I can see that 4X, what would be another way of describing 4X? Another way would be that is the perimeter. So 1/2 times perimeter times the slant height. And so this is the formula we come up with for lateral area. And so let's go ahead and go back to our picture here. Okay, and so since a prism is different, and if you guys have a highlighter in front of you, can you guys go ahead and highlight that formula is right here. And total area would be, you take the lateral area that you got from above, and then you add the area of the base. And since a pyramid only has one base, we would only have to add that single base value. And so again, let's go ahead and just remember that B is equal to area of base. Okay, so our last formula that we see right here is that of volume, and volume is 1/3 times the area of the base times the height. Okay, so a lot of the times what's given to you is a description. I'd like you guys to practice drawing as best as you can. So you can hit pause here and go ahead and try to draw for me. A regular square pyramid has a base edge of 6 and a lateral edge of 5. Now let's see what we can do to find the values of A through F. Okay, so let's go ahead and draw what the description is here. So we have a regular square pyramid. Okay, and the description also tells us that the base edge, so one of the edges of the base is 6. And one of the lateral edges is 5. So a couple of things we're missing here. If we're asked to find all of these values, we'll eventually need to know what the altitude is, and then also what the slant height is. So if I go ahead and draw the slant height in, the slant height is this value here. And the slant height, remember, that when you drop the slant height down, it divides one of your lateral faces into two congruent triangles. So this happens to be 3 in this picture. Okay, so if we know that that's 3, we can use Pythagorean theorem to figure out that the slant height therefore must be equal to 4. And we note that the units of measure is m. Again, because my pyramid's a little bit crooked, hopefully the point is still clear, that the base, when you drop the base down to the center, so that should be the center of the square pyramid right there, forms a right angle. And if you guys can see, I'm going to go ahead and connect it with the point that connects the slant height to the midpoint of the base edge. We see that there's a triangle that's formed. Let me go ahead and see if I can highlight that triangle for you. Okay, so within there you see that there's a triangle. Okay, and that's the triangle we're going to focus on. Okay, so if the slant height is 4, this value here, and let me go ahead and draw an arrow to that so you can see. But let's go ahead and, this is the triangle that you see. And I'm going to go ahead and highlight that also yellow. Okay, so those are the same triangles. We can see that the slant height we had figured out was equal to 4. So this is the slant height. Okay, this is directly halfway between, and I know it's not clear in the picture of the pyramid, but this is half the length of the side of the square. Since this is a regular polygon, that altitude divides the side into equal halves. So this is 3. And so the question is, what is the height of your pyramid, the altitude? Okay, and so we can see we can use Pythagorean theorem here to figure out that h is equal to 4 squared minus 3 squared, and then the square root of that. So we have h is equal to 16 minus 9, or square root of 7. Okay, so the value here is square root of 7. I like to figure out all of these values first before I then go back and answer the questions that I need. So now I can fill out a couple of these things. Slant height is equal to 4. Okay, the lateral area is equal to, from the previous demonstration, it was 1/2 PL. If I take a look at the square, each side of the square is 6. So there's 4 sides of the square, so 1/2 24 times the slant height, which is equal to 4. If you have a calculator in front of you, we can input that into a calculator. Half of 24 is 12. 12 times 4 is 48. So we have that the lateral area is 48, and that's meters squared. The above units is meter. The base area, since the base is a square, would be 6 squared, or 36 meters squared. For a total area, so in order to find the total area, you would add these two values to get the total area, and that would give us a value of 84 meters squared. The length of the altitude, or the height, we calculated was radical 7, and the volume is 1/3 times the area of the base times the height. And so in which case, if I plug everything in, that would be congruent to 1/3 times the value of the base, the area of the base, which is 36, times radical 7. So 1/3 of 36 is 12, so 12 radical 7. We want to remember that our units of measure are cubed. Anything that is area is squared, and anything that is not is just meters. Okay, so now let's go ahead and try 2 on your own. And so with 2, I'm going to take a moment and erase the work right here that you see so that I have some space, and then cut and paste so that I have some room to work this example on. So copy. Okay, so here you have a regular triangular pyramid. Okay, so I usually like drawing the lateral faces, and I know that there's 3 of them if there's a triangle. Remember keeping in mind that all 3 sides of the base should be congruent. So here you have a regular triangular pyramid has a slant height equal to 9. So let me go ahead and draw the slant height here. And that value is equal to 9. And we're given that the perimeter, so all 3 sides of my regular polygon, which is then an equilateral triangle, these sides are all congruent to each other, that all 3 of those must be equal to 12 added together. So that makes each one of these sides equal to 4. So 4 times 3 is 12. And so if I go ahead and let's go ahead and highlight this so you guys can see this a little bit more clear, that if I were to take one of the lateral faces and redraw that, let's go ahead and try to make that triangle right there. Okay, and what we're trying to figure out is this slant height, and I'm going to go ahead and color code it so that this is all yellow. So that's what I'm trying to figure out. So what I do know is that this length right here is 2, half of 4, and that this slant height was given to me as 9. And so what I now have to figure out is what the if they're asking me to find the lateral area, I would have to know for the lateral area what the perimeter is and what the slant height is, which I have. So the perimeter was given to me as 12, and the slant height is 9. And so if I multiply those together, I should get 54 units of measure centimeters squared. Okay, the base of this equilateral triangle, keep in mind, is the base is an equilateral triangle. So if I remember from the previous chapter, that would make the formula rad 3 over 4 s squared. And each one of the side length is equal to 4. So if I go ahead and plug in rad 3 over 4 times the side squared, 4 squared, and simplify that out, I have rad 3 over 4 times 16. Okay, I reduce that. 4 goes into 16 4 times, so my base has an area of 4 radical 3 centimeters squared. Now, this one doesn't ask for volume, so I don't have to go ahead and figure out what the altitude is. So for the total area, I have the total area being, if I were to cover that entire pyramid, I had to wrap that up. I'd have to add the area of the lateral faces plus the base, which would get me a value in simplified radical form of 54 plus 4 radical 3 centimeters squared. And I would not need to enter that into a calculator, and I cannot combine the 54 and the 4 rad 3 because they are not like radicals, and that's something we want to keep in mind. So I believe there's one more example left. I'd like you guys to attempt that problem on your own. I will go ahead and write out what the answer is. If you have any questions at our next meeting, you guys can go ahead and ask me. But the question for this one is the height of a regular triangular pyramid is 6. So keep in mind that the height, they don't say that that is the slant height, that's the one that goes straight down the middle. The radius of the base is 8. Find the base area and the volume of the pyramid. Okay, so the radius of the base, again, the radius of the base, you want to think of that in terms of polygon. And that is from the center of the triangle. And let me go ahead and draw that picture for you. So if this is the base, what they're describing is that the radius that's given to you is from the center to the vertex is equal to 8. Okay, and so you are trying to figure out the base area and then the volume of the pyramid. Okay, so the question is, how do you find the area of this? Think back to the previous unit, and I'll give you a hint. The area of a regular polygon is 1/2 AP. Okay, so we'll continue with this, and you can verify that your answer for the area of the base is 48 radical 3, and that your volume is 96 radical 3. I can answer questions on this if you have further questions at our next live class meeting.